All right, welcome to part 4 of accessing and creating data structures in SAS. This is going to be the last part for accessing and creating data structures, and then we're going to be moving on to another section. So first, just really quickly, I'm going to explain how SAS stores date and time values, and it stores them in 3 different ways. The first way is the date method, which counts the number of days since January 1st, 1960. And then there's a time method, which is basically a timestamp for any given day, which the value will start at 0 at midnight and will count all the way up to 86,399.9999, which it will then reset once it hits the following midnight. And then there's the date time method, which counts the number of seconds that have passed since January 1st, 1960. And then one important thing to note is if you're dealing with dates before January 1st, 1960, you're going to have negative values. And then we'll have a chance to see what this looks like later on in this video. All right, now we're going to move on to using SAS informats to read common date and time expressions. Excuse me. So I'll go ahead and type this up and then I'll explain it after I run the code. So we're going to use a data statement. We're going to create a new data set called sample data, semicolon. Then we're going to say input at 2, 8, 1, dd, y 8 dot. And then at 11, 8, 2, y 10 dot, semicolon. And we're going to use data lines to input some data. And we'll just use today's date twice to demonstrate both of these. So 22-06 20 space 22-06 2020 and semicolon. So go ahead and run this. And just check the logs really fast. Okay, no errors or warnings. All right, so you can see we typed in today's date, and in both of these columns, we've got numeric variables. And like we just went over, should be the number of days that have passed since January 1st, 1960. And then let me go over this code a little bit, just so you guys know what's going on. So we created a new data set in the work library called sample data, and then we specified that we were going to input 2 variables called date1 and date2. And then we told the program where to look to start looking to find this data. So for example, this pointer tells the program to look at position 2 in our data lines, or our input data if we were using another method. And the pointer here tells us to look at position 11, but that's a little bit outside the scope of this video. The important thing is we're using the informats. So here we told the program what format our first variable was going to be in. So this is ddmmyy 8 dot, which the 8 is the number of characters. So 1, 2, 3, 4, 5, 6, 7, 8. And then same over here, we've got 10 characters here. And these are pre-specified by SAS, and there's many more than just these 2, but these are some of the common ones you'll run into. And then, yeah, obviously we outputted date 1 and date 2 variables with these 2 dates in here. So this isn't very useful to us. So the next step is to use SAS date and time formats to specify how the values are displayed. So let's just cut this and move it down. Tweak one line of this code. So right after that input statement, we're going to put a format statement. We're going to say format date one as ddmmyy, just like we did before, but now we're telling the system how to display our variables. And then date two, we're going to say ddmmyy 10 dot. Let's save this and run it. Look like we're good in our log, and now we have 2 readable dates. All right. So that's all we've got for dates. Let's go ahead and comment this out. The next thing we're going to be going over is using the where statement in a data step to select observations to be processed. So we're going to start using the maps.africa file again. I'll just pull that up so everyone can see what that looks like. All right. So we're going to create a new data set in the work library called test data. And we're going to set it equal to maps.africa. We've done before, but the key thing here is we're going to use where and then say where density, which is a variable over here, and we're going to say where density equals 5. And luckily, the program's intuitive on this matter, so we can say where density equals 5, semicolon, and then run it, and it should work. Put it on the log, and now our output data, which is work.testData, is equal to maps.africa, where density equals 5. You can see we've got 5s all the way down. All right, so then the next thing we're going over is how to subset variables to be output by using the drop and keep statements. So let's go ahead and comment this one out so we don't keep running it over and over. And we're going to just use test data again. So we'll be creating a data set named test data in the work library. At this time, we're going to drop the variable called segment, which is this column right here. And then everything else stays the same. So set maps.africa where density equals 5 and run. Log looks good. Then everything here should look the same, except we don't have the segment column anymore. And then you can do the same thing if we wanted to drop everything except for the segment column. We could just say keep segment. And we'd have maps.africa where density equals 5, but we'd only have the segment column. All right, so that's not too hard. We'll go ahead and comment that out. Then the last thing we're going to be going over is using the drop equals and keep equals dataset options to specify columns to be processed and or output. So the idea here isn't too different from the last one, but the syntax is a little bit different. And then there's some specific situations where you might want to use one over the other, but it's not super important for us to cover here. So we're going to say data, and then we're going to keep going with test data, semicolon. This time we'll go ahead into our set, say set maps.africa. Set here, we can say parentheses drop equals. Then we'll hit our semicolon where density equals 5. Run it. Check. No errors or warnings. So yeah, this is maps.africa where density equals 5 and it's excluded the segment column or variable. And then, like you can probably guess, if you do keep, we can just say keep equals segment. But then the key syntax thing here is if we want to do multiple specifications, you just separate them by a space. You don't need commas or anything like that. So segment ID. This is if we wanted to keep the segment ID and density columns or variables. So we'll save that, and we'll run it. And here we go. This is the maps.africa dataset where density equals 5, but we've only kept the segment density and ID variables. All right, well, that's it. If you guys have any questions, let me know. And then you guys can look forward to the next section. And then if you guys haven't caught on already, I'm kind of going over the exam content guide for the SAS Base Programmer certifications. So you can follow along with that guide too. And maybe I'll leave that in the comments or something. All right.